Welcome to AWS for AI podcast.
आज मैं आपको एक सीक्रेट बताता हूँ। मैं हिंदी का एक भी शब्द नहीं बोलता हूँ।
وأنا حقيقة لا يمكنني التحدث باللغة العربية.
And yet, if you want to understand how we did this,
Tune in to this podcast.
Welcome to the AWS for AI podcast.
welcome to AWS for AI, the podcast where we explore cutting-edge AI solutions and the innovators behind them. I'm your host, Hamza Mimi, AWS Solutions Architect. And today, I'm thrilled to welcome Akshat Prakash, CTO and co-founder of Camb.ai. Ak is a researcher, a Carnegie Mellon University graduate, and a serial entrepreneur. Prior to Camb.ai, Ak worked at Apple as the youngest member of the Siri team, where he perfected his generative AI skills, working with the likes of Jan Goodfellow, the inventor of GAN, the generative adversarial network. Ak moved on to create Camb.ai to solve content localization, developing foundational models to dub content in more than 140 languages, while preserving emotions, background, and speaker voice and tone in near real time. Camb.ai have already released its 7th iteration of MARS models and counts amongst its customer giants like Major League Soccer, Australian Open in sports, or IMAX in film industry, and a lot more. Camb.ai are also the first to provide a text-to-speech model on Amazon Bedrock Marketplace with MARS 6. In this episode, we'll explore the technology behind dubbing, translation, and content localization, but we'll also dive deep in what makes this Dubai-based startup such a great example of global success. Ak, it's a great pleasure to have you with us today. Welcome to the show.
Thank you, Hamza. That was a great intro. I appreciate it. Thank you.
Thank you. So before we go into the technical aspects, I just wanted to talk to you about your personal story, what brought the interest you have in AI, and all of your background getting to the point where you're creating Camb.ai.
Yeah, absolutely. So there's actually two stories here, and I'll run them in parallel. So I grew up as a person who loved mimicry. I loved mimicking my favorite Bollywood actors, even animals at times. I was really into speech patterns from the start. And then, while AI wasn't a craze as a teenager, I loved physics, and I was your kid who was always building like science projects for fairs and stuff. And somewhere along the lines, I met with computer science, mathematics, and I saw this entire world where coding could just make my science projects so much better. And I think I brought all of those interests together to CMU, Carnegie Mellon, where I did my undergrad. And that's where I kind of fell in love with speech and generative AI. And from there, as you mentioned, I got the privilege of working at Siri at a time when not many people know this, but in hindsight, we were creating one of the first versions of a chat GPT-like system at a time when Ian was leading the Siri AI ML group. So I was very lucky to be kind of part of that cohort of folks that had a front row seat to the chaos that was to be unleashed in 2022 going forwards and the world that we live in today. So that's like my brief journey so far and what's gotten me into Camb.ai.
Okay, then Camb.ai, what's the story there?
So, yeah, I think Camb.ai, when you think about it, really brings together years of personal experience of whether it's like growing up in countries like Ireland when I was like 9 years old and trying to make new friends, or even when I moved to the US from India for my undergrad, where even though I might have spoken English really well, even just the accents being different created a lot of barriers for me. And of course, this is not a problem that is like new by any means to me. It's something that a lot of us have potentially grown up with of language barriers and not having enough opportunities or not being in the right spaces just because of maybe the language you speak or the accent in which you speak it in. But equally interesting is I've had the amazing luck and fortune in my life of starting Camb.ai with my father, who is our CEO. And I think what binds us towards this company more than DNA is actually a shared experience. So 30 years ago, he couldn't just like order a cab on Uber or whatever he wanted on Talabat to eat. I can do that. And our world has changed so drastically in the last 30 years. But language barriers have remained pretty much the same. And when you actually think about it in that context, you can take a seat back and you're like, wow, yeah, I mean, it really hasn't, even though the world has changed. So he comes from a great background of business and building large businesses globally. And kind of my background is in speech research and general artificial intelligence. We were like, we want to build something together and build something meaningful. And Camb.ai was the right answer to that.
I can so really deeply buy into that experience of you do speak the language, but you don't understand the culture.
Yes.
And then you're missing a lot of context and you don't actually understand what people are saying.
Absolutely. I always love to give the example of sports because sports is a great way to understand this. Like, let's say you're watching a baseball game and the commentator says, "Oh, and the ball goes and peppers off of the green monster." Now, I speak perfect English, but if I didn't watch baseball, I wouldn't know what that actually means, right? Yeah. And so that's sports is very representative of that. Even if you know the language, if you don't know the culture, you're kind of, in some ways disincluded from it, right? And I think that's essentially what Camb.ai solves for. So while many people think about this as translation or text-to-speech or anything, I think our mission is really, when you think about it, making content more culturally adapted to new audiences, which I think is the missing piece today.
Interesting. You're solving for culture.
Yes.
Across the world.
Absolutely.
Nice. Before we go deeper, what does Camb stand for?
So the name Camb is actually, funny you ask, is deeply personal. If you were my close friend from childhood, you would immediately know. But Camb.ai, since both me and my father started it, it only made sense that we named it after something extremely personal. Now, the name itself, if you jumbled it up and, reordered it, it actually spells out my mother's name. But there's an even deeper meaning behind her name, which means unlimited power. In a certain sense, right? And so we felt that it's very representative of the unapologetic nature in which we are building this company for the globe, sitting here in Dubai, and also personally meaningful, because at the end of the day, we are a family business.
Exactly. It's a personal story bringing a solution to the world.
Absolutely.
I've heard you talk a lot about the Mamba mentality, and at first I thought you were talking about the SSM architecture. Can you speak about what's to you the Mamba mentality?
Yeah, I mean, outside of architectures, I think generally what I see as being an entrepreneur is the ability for you to create things is becoming easier and easier as kind of years go on, days go on, and so. While creating new stuff is becoming easier, making businesses is never going to become easier. It's always going to be the hard grind. And the Mamba mentality refers to one of my idols, Kobe Bryant's mentality, where he says, it's actually plastered all over my room. So I'm so hyped that you bring this up. Every day I walk into my office room, it's right there. But essentially the mentality of getting better at what you do every day, even if it's like 0.5%, you just keep getting better at what you do. And I think Kobe Bryant is great to hear because he's of course legendary and he's a great basketball player and everything. But beyond that, I think he taught the world something so special that not only so many athletes kind of imbue in their lifestyle and in their profession, but many, many business folks follow some version of this Mamba mentality to be like, it's, of course, there's skill and there's luck, but then there's a lot of hard work and a never give up attitude, which people always say like failure's a stepping stone to success or don't give up. I don't think that quite captures what it is that takes to build a great business or a great company. And I feel more so that the Mamba mentality does that right? So that's what it means to me. It's just a way of lifestyle, and it's funny because now it's an open secret. If you interview at Camb.ai, you're unlikely to get a job if you don't know what the Mamba mentality is. That's our ring of fire.
Nice.
And that's, at the end of the day, beyond all of the cool tech we've built, that is our secret sauce.
Interesting. Before we go to the tech, what are some of your customers? Where are you operating? And where are you based currently?
Yes,
as a company.
Absolutely. We call Dubai home, of course. And Dubai offers so many cool benefits of operating a company here because, one, it's just in the center of the world, right? Us as an internationalization and localization company, we have to work with customers everywhere from Australia, Japan, Europe, different parts of Asia, Africa, and North America. So while the inklings of the business started when I was still in Sunnyvale, and we are a US company, it just made less and less sense of how we could scale a fully internationalization business and an international business, which is day one, from the PST time zone, right? And of course, family is here and everything is here. So Dubai made a lot of sense for us to grow the business out of. And today we're very proud to be known as a Dubai-based company, and I feel there's many more to follow. So that's where that's our kind of home soil, home ground. We're right here. But what we've done is, instead of taking a mentality of importing AI and just building it for the UAE or anything, we're very, very proud, and I look up to great entrepreneurs here as well who have a similar mentality of, we don't want to just import AI for the UAE. We want to build AI and export it to the world, right? And that is something that's very special and kind of personal to Camb.ai, because today our customer and client base spans everything from an Australian Open, which is in Australia, to a Dentsu in Japan, to a League One, which is essentially the French Premier League. PSG won the cup, so yay PSG. So they're one of our customers, to even North American based sports leagues and brands like IMAX and NASCAR. So very, very, very proud to have built a company out of Dubai that serves truly a global base and large brand names. And to kind of give you an example, which I'm very excited about, and maybe dives a little bit into the technicality already of it, is 2 weekends ago, we became the first company in human history to live stream a race of any kind into multiple languages. And we actually worked with NASCAR to live stream their Mexico City race into Mexican Spanish in real time. So fans and viewers on the official NASCAR app, they were hearing that live raw commentary from English into Spanish in real time, right? And why I bring this up is, of course, it shows a lot of technical maturity at the level at which we're able to deliver content for such large brands at such high stakes, right? We're delivering localized content to native speakers, right? It doesn't get, it's always like launching a rocket, honestly, when we do a live stream for such scenarios. But I think what's super cool about that is, I think more and more when you think about evaluating AI, I made this post on social media recently, is like, a lot of companies talk about latency and accuracy and word error rates, but if you really want to put AI to the test, this is how you do it. You do a NASCAR race in real time. And I think that's very satisfying, because of course I'm the CTO. It's like a technical feat for us, and of course it shows how competent the team is, and of course how good the technology is. But I think that also segues into just how do we think about selling AI to enterprise? How do you measure results? And is it just like accuracy scores, or there is something deeper to that?
Absolutely. And there is also a feeling of that man on the moon multiple times.
Yes, yeah, it really does.
Because of all the technical challenges, but also the business challenges, and getting to that moment with everything just falls into place.
Yeah.
And yeah.
And talk about, because the race is like, it's happening in the American time zone. So I was in Dubai at that time and it was like 2 a.m. Of course, you can't sleep when that's happening just out of the excitement. So I actually had the NASCAR app and I was listening to our feed I speak a little bit of Spanish, poco. But it's very, very thrilling. And it is exactly like you describe. It's like a man on the moon moment. And every time we do something like this.
So can you talk a bit? I know you do the last mile work, but you also have products that you've built. Can you talk a bit about all the products or some of the products that you have developed yourself at Camb.ai?
Yeah.
From MARS, BOLI, but also some of the public products that you have.
Yeah, absolutely. So I think when we started this company, what we got the tag of is being an AI dubbing company, which is all right to say, like, yeah, fair enough. Like a lot of what you see in the media about us and stuff will always relate to kind of AI video localization. But today, when we work with enterprises, who we are known as is the localization infrastructure for their enterprise. And I think that encapsulates exactly what we do. What we help our enterprises do is identify localization use cases and then help them scale through all their use cases in localization, where maybe the hardest one is something like doing a live stream in multiple languages, right? But we do that full slate of work. So we have a SaaS platform called Studio, and you can do like VOD dubbing, you can add subtitles, you can even translate documents and websites. But what it gives you is like a full platform tool so that when an enterprise is thinking about its long-term localization strategy, Camb.ai's foundational technology and all the product that we've built on top of it is just what they use, right? In a very standardized manner, because, given that we can do live streaming in high stakes scenarios, of course we can add subtitles to your videos, right? And so that's kind of the play we have. But some of the products that we're very excited about, of course, is Dubstream, what we refer to as the live streaming product. But then, we have very cool new features, everything from VOD dubbing. So, you could be like a large media house and you could use it to upload your content, video, and translate it into multiple languages. Many media houses use us today. We've actually put Arabic movies into theaters of late, and because I'm kind of mentioning this before, we chatted about airing that at the Red Sea Film Festival and such. So really anything that you can think about that's hard content and you want to localize it into another language, we have products for that. Now, well, that's more of a product utility layer and how that manifests for enterprises, which is very important. At the core of it, we have two engines, right? And that is some of our foundational work. The reason we had to build these models is that when we started the company, there was actually no OpenAI actually. Of course there was OpenAI, there was no ChatGPT on the scene. That it was not a thing, right? And even so, even to this date, speech research, I feel, is we also always used to joke around at Carnegie Mellon that it's like a poor man's job, because for some reason, and I'm sure you'll agree with me, there's very cool text models, there's very cool image models, but like, who's the Mistral of speech today? It's like a question mark. Like, why isn't, like, maybe there is, maybe Camb is, but that's kind of like, so, the motivation is that there's a lot of unsolved problems in speech. And so BOLI and MARS are some of our frontier models that enable content understanding. So BOLI is a model that is multimodal, and that now even more recently can take in video and audio at the same time and directly output translated text. And MARS is our kind of generative speech model. So it's like, it can, it's more akin to your classical TTS models, but with a few improvements that actually enable things like, that we do live or otherwise. So that's foundationally what we have. And kind of as you briefly mentioned, very stoked to have built these models, open sourced them today. Like some of the best labs in the world use models like MARS. I know like a ton of folks at Stanford and MIT, they use our models for everything from data generation for research work, speech data generation, to just building on new architectures from MARS. And now even being on platforms like AWS Bedrock to be some of the first speech models on there. So that's kind of our entire if you want to call it like the product layer, and then more the foundational layer.
So you're working on the forefront of research in the speech field, but you're also building the foundational model and the products.
Yeah.
I want you to touch on, you're working on use cases in different industries. When do you decide what needs to be solved in the foundational model as versus in the adaptation for that specific use case versus in the products?
Yeah, that's actually a great question. So I think the way to understand it is most companies, and not to be on any high horse or feel that this is a biased opinion, but I feel a lot of companies that will create value will have understanding and be able to operate on both layers. And I think it's becoming increasingly important too. You need to be of course, great product expert and build great product and use cases. But then you also need to be able to understand the model layer and develop the model layer. Why I say that is actually speech-to-speech translation is a great example. So, of course, we want to build new features that enable you to maybe do speech editing. So let's say I make a quick mistake here and you want to quickly edit it out so that it's natural, right? Maybe you want to build product around that. But then for that use case, you also need to be able to go into the model layer and turn a text-to-speech model into something that can do what we call speech in-painting. So I'm sure we've all kind of heard about, all the great image models out there today where you can kind of extend your images or edit them on the fly and such. So all of those properties are in-painting applied to image, the same thing you could do in speech. Now, if you're just a product company and somebody came to you with that use case of speech editing, you'd be like, I don't know. I just do text-to-speech and I can give you text-to-speech. No. If you're just a foundational company, you're like, oh yeah, I can build that. But you have no way to understand customer pain points and workflows, right? No. And I think as AI is becoming more and more democratized on the foundational layer, it is these types of kind of verticalized problems or insights that continue to differentiate you from giant hyperscalers, right? And, and kind of this is a co-growth ecosystem, right? Everybody wants to innovate. Everyone will innovate. Everyone will create their frontier models. But I think what will continue to differentiate great startups and great companies is not only, I guess there's a third thing, not only them being great product engineers, great researchers, but also being extremely adept at the problem they're solving. So you mentioned last mile problems, right? Where all the secret sauce is. Like when you think of something like AI dubbing or speech-to-speech translation, there's so many last mile problems that you need to get right. Even if you have a great text-to-speech engine or a translation engine, you still need to solve things like, how do you manage like a feed that maybe has 5 anchors in a news feed and ads in between, making the total number of speakers like 100. Right, speaker diarization is a huge unsolved problem in speech research, and my friends at these other companies that are building products for speaker diarization will agree with me that there's many unsolved problems in speech, which makes this a very attractive kind of place to keep innovating and keep solving these last mile problems.
So by owning the full technology stack, you're basically able to fine tune whenever needed in the right place, and having that control over the end result.
And
your business model is also you're interacting directly with the end customers, right?
Yes.
So you also build whatever needed for that last mile.
Correct.
to make it work, right?
Yes, okay. Absolutely. I mean, at the end of the day, a customer honestly doesn't care about AI. They care about getting their job done.
Exactly.
Whether humans are doing it, whether AI is doing it, whether it's a mixture of in between. They just want content localized in every language fast and reliably and high quality, right? So you have to get the workflow right, but at the same time, you need to be able to take like strategic research decisions of like, this is a great use case that's opening up, and there's clear market here. So of course, we want to be able to extend our capabilities in the model layer as well. And that has great benefits into like leaking over into more use cases and such.
So you're trying to solve multiple problems. You're trying to solve for accuracy between 140 languages and dialects. You're trying to solve for live stream and performance. You're trying to solve for additional adaptation into the product. How are you building all of that?
Yeah. So this
how
is
do you do it?
Yeah. So it's a great question because you sound like an investor, and no, because it's great because this is a common question. Like when you look at this product, it seems the impossibility of it and the breadth of it seems like you couldn't be getting it right, except that's where our strategic secret sauce was, right? Going back to what we were talking about at the start of our chat. Instead of thinking about localization as 100 use cases and then building 100 features or 100 products around it, our research thesis was simple, that if we solve the hardest problem first, you can almost think about it like the hardest problem being the biggest iceberg, right? And once you crack that big iceberg, all the boats behind you flow through just fine, right? For us, that problem was live sports, and very explainably so, right? Live sports has everything. It has great emotion, craziness going on, right? Has multiple commentators. It, like I said at the start, has a lot of weird lingo, like doesn't even make sense in English or the source language. There's a lot of background. There's a lot of unpredictability. Like in a sports stream, you could go from commentary to a sideline interview to an ad put in between. So it's like very, very dynamic, right? And so actually when you see it from this perspective, you realize, wow, yeah, if you can get live sports right, you actually get a large body of work, right? Where all the other types of content is strict subsets of that. So for example, audiobooks, right? We're able to do audiobook generation for some very well-known companies today. Audiobook maybe doesn't have all that background going on and maybe craziness going on, but it has a lot of emotive speech and nuance to it. That is like a strict subset of sports. You look at drama, that is a strict subset of sports. Or even, podcasts like these, while we might not be shouting at each other, but there's enough emotion, there's enough, back and forth, we being two speakers, you start to see how every content domain is a strict subset. So that was our strategy, and that's worked out really well. So now we don't have to solve it's not like, you solve the 100 problem and then it was like we get a 101 problem or a 102nd problem. We've solved all the problems roughly that we feel you need to get right for this to be viewed by native fans and viewers and everywhere. Now it's just about making sure that each of these things that we've unlocked, whether at the model layer, whether it's somewhere in between, or the product layer, that we continue to get from 95 to 99 to 99.9, and always kind of covering that last mile where innovation continues to lie.
Excellent. Let me get into the technical aspects now. MARS series of model. Let's start with, currently you're working on MARS 8, right? MARS 5 was a mixture of regression model and non-regression. And when you're working in sports industry and trying to solve for live, speed and performance matters. Regression models are known for being slow, right? How do you manage that combination of both? And then how did you evolve your models after Mars 5?
That's a great question. So Mars 5, just to give some context, Mars 5 was one of the first, or the first model that we open sourced back in 2024. And shameless plug here, we actually trained that fully on AWS infra. And AWS was a big help in that. Right? We couldn't have gotten over the line without the necessary help from AWS. But when we had open sourced it, it quickly became to know as one of the first models that could do prosody as hard as sports commentary. So you see some of the videos and you should try out the model even now, even though it's like more than a year old. Even back then, it could do really hard prosody, like shouting and such, which wasn't really a capability that any speech models had back then. And most other parties were like working on image generation and text generation. Now, coming back to your point on we wanted to always solve for such use cases where speed matters, but prosody and performance, the quality matters as well. That's why we used a combination of autoregressive and non-autoregressive. So in MARS 5, the way the architecture works is the autoregressive part, which is somewhat, of course, slower, will get more of the coarser features, right? More of the underlying depth of your voice. So you can make a parallel between the autoregressive part will kind of decode the identity of the voice, or maybe the timbre of the voice, and then the non-autoregressive part will in a much more speedy fashion decode some of the more finer grained nuances of the voice. So maybe the way the husk at the end goes, or the some of the finer grained features to just get it right. Or when a commentator is shouting, how does the end bellow end? And so it's really a combination of if it was a full, and today there are some innovative speech models that are fully AR based, which is great, and they work fast enough. It depends on the use case. But back a year ago when we did it, we thought this was a kind of a great combination to get, great accuracy on the prosody, get the base stuff right and the finer features, but also get the speed right.
How don't you get the worst of both? Isn't the autoregressive slowing down the non-regressive model?
Well, the thing is that you don't want to do the opposite, right?
Yeah.
You don't want to decode kind of the coarser features through an R model because that is fundamental to most of the information in the speech, right? And you don't want to get that wrong. So the trade-off here is like, when you're doing some of the finer grained features faster, you could get it wrong, but then it's more of the finer grained details. You won't get the entire maybe hallucination of the word wrong, or it going off the rails. Yeah. So I would say it's a good trade-off to have something slower and more effective for the coarser grained, and then have something faster for the finer grained. And then it's a good trade-off and combination of both that led us to that architecture.
But you evolved from that architecture afterwards. Where are you now?
Yeah, so I mean, the interesting part of, and I always talk about some of this stuff in the middle as well, where you mentioned MARS 8. One of the things that we are very excited about is we have gotten very far in solving this problem of what people call speaker entanglement. And, I was talking about coarse features and finer grained features in voice before. How do you differentiate your core voice identity, you as Hamza, your voice, from maybe you talking when you have a cough or a bad day, or when you're sad or when you're happy, right? In speech, it has always been increasingly hard to differentiate what is fundamental to somebody's voice versus what is more nuanced and not fundamental to their voice. And some of the great capabilities that we're able to unlock with the latest generation of MARS is really separate both of those distinctly. So again, going back to the example of any type of content, if we're transferring performance from one language to the other, previously you would have to maybe clone the entire voice and have a static reference of what was going on into the target language, right? So it would sound like the person, but it would not ebb and flow as the content changed over time, right? And so, of course, we solved that with things like MARS 7, MARS 6, right? Where we could, go, almost from frame to frame and have the same speaker, even within the same speaker, change their voice slightly in a way that would be authentic to the performance. But then a problem comes and like, well, what if you don't have the ethical right to use that voice identity, right? Like you can't just like steal somebody's voice, right? And that's actually, it opens up a big problem. Then what do you use as a reference to kind of mimic that emotion through and dub that performance through to another language? And so that's where powerful models like MARS 8 really come in, and we've been able to disentangle prosody from voice identity. So what that means is we can still transfer over how the emotion is ebb and flowing from the original into the target, but we could kind of replace it with a completely different voice, right? And that, this is just a deeper insight into some of the million last mile problems in speech research that largely still unsolved. I mean, there's some research now in it as well, but lets you actually differentiate between something that looks good just as a paper versus stuff that is ethically right, that you can actually ship as a product and large enterprises can use in front of many, many fans. So this is kind of how like our decision making, our architectural decisions have changed. In between when we did MARS 6, it was another kind of like business and research decision that we had to take where I think MARS 5 was a 1.2 billion parameter model, which is not big by any means. That's extremely tiny by how things are going these days, right? But for a speech model, it was quite large. I think it was one of the biggest speech models out there when we had released it. Now, one of the use cases that we wanted to unlock is that, you know, especially as a scrappy small startup, is that we probably can't immediately train like a 400 billion parameter model. Right? We probably don't have the resources to do that. So we decided to play to our strengths and maybe more limited resources and limited time on what could we do off of one 8x H100, right? If we were just given that, what could we do off of that? So the constraint and also the business need of speech applications to be everywhere, not just on the cloud, but device, forced us to kind of think of architectures like MARS 6, which, you know, when we published the paper was around 70 million parameter. It was a 70 million parameter model.
That was impressive to me, by the way.
Tiny, like absolutely tiny. But we still were able to innovate in ways that it showed performance akin to many models that were way larger its size, right? And so that's kind of been our research journey so far. A lot of it has been dictated with how research is going on in the field, but also with our business constraints and kind of objectives. So that's how our stuff has evolved over time.
You touched on multiple points I want to dive deep into.
Yeah.
Voice cloning. So now with MARS 5, you can still get that general feeling and expressiveness without getting the basically the fingerprints of the voice. So if you don't have the legal rights, for example, you can still use that material without actually getting the voice of that person.
Correct.
And getting still that general expressiveness. You also touched on the performance aspects. I really want to dive into this one. 70 million? Why even? So most of the models, as you mentioned, are like 70 billion are considered now small language models. Is there any actual business case for very, very small language models? Because now even in small hardware, you can run 1 billion models.
Yeah, absolutely. No, it definitely depends on the use case and which type of model it is, right? So, you know, if you go into the world of the llamas of the world, right, there is enough deep vertical research within that one model that you can start exploring ways to port 1 billion to device and even small chips and such, hopefully pretty soon, right? You know, Llama CPP and such and Ollama, they're all great examples of how you can get such models working in small spaces. Now that's where, like I said, speech research is a poor man's job. There hasn't been really enough innovation or even enough people around speech to create that body of work where, oh, of course, if you had a billion parameter speech model, here's the rule book on how you get it to work on device. In fact, I would go as far in saying that there's not even a rule book on the right architecture for speech right now. Right? I can't claim, nobody can claim that they have the right architecture done for speech because it's still, I mean, there can be a million things done. So fundamentally, you know, it's not like we could have taken a larger speech model and just like do some smart tricks and get it onto device. Like we had to fundamentally create architectures that could run on small devices. And that was essentially the business need. You know, there are many use cases in the world that just won't work if you continually called APIs from the cloud. I'll give you two examples. And I think they're very meaningful. In about a few years, it's said that there'll be a few million robots around us. All of them will have speech interactive capabilities. All of them will be highly personal and within your homes. So think about it just from an economic standpoint, right? A few million, 10 million, maybe one day 1 billion robots deployed within your house. You're interacting with them for maybe 3 to 4 hours a day, and they're generating fresh speech content for 3 to 4 hours. You do the math on that, and Sam has always said that you needed some models to train, and you need a lot more for the usage and inference. Yeah. The economics of this has started to look a little shaky and wobbly, right? And that's where it opens up a lot of interesting need, like almost a practical need to have models that are small and can run right on the edge. Now, instead of thinking about a model like an ML model that needs a large GPU to run off of, if you just considered it as like a robotic part, like the hand of a robot or the heart of a robot, right? If you just kind of put yourself in that frame of mind, then you realize that, yes, you now, instead of putting a model on the cloud and consistently calling APIs and the economics just not working out and throughput and latency issues, you can directly put that, first of all, keep something as private as speech directly within the robot as a part, and do unlimited generation. Like as long as the robot has battery, it can keep talking to you. And you can actually extend this use case across gaming. Like a lot of the future of gaming as we see it today across all platforms is these open world interactive games where something like, who doesn't love GTA, but like GTA 6, it's not like maybe pre-recorded interactions with NPCs or stuff, but you could actually have meaningful conversations with NPCs, right? But to be able to generate that level of content personalized just becomes economically wobbly doing it on the cloud. So there's a whole world of getting especially speech models to the edge, because at its very root, speech is how we're just going to interact with everything. And so there's all the more reason to build edge first.
And it goes into your approach of solving the big problems first.
Yeah, absolutely. Of course, if we can get it into like a small microcontroller,
you can do anything.
We can definitely get it larger and scale up. With a lot more of AWS's help as always. But yeah, that's kind of the mentality there.
I want also to touch on one of the architectural decisions you made. You have two models. You have BOLI and MARS, text-to-speech and then speech-to-text. Now we're seeing speech-to-speech models coming in. From your perspective, what's the best architectural choice? Why have you gone for two models instead of one?
Yeah, so I think in a long enough horizon with enough data that is parallel, aka you have enough data from, let's say, English to Spanish. I mean, there's probably enough between English and Spanish, but when you have enough between every language pair that you care about, I think speech-to-speech models will start ruling the roost, right? It's safe to say, on a long enough horizon. But today, there's some fundamental problems that restrict a company like ours just going full speech-to-speech modality, right? Some are more practical, even on a long enough horizon, right? So the fundamental issue today is there's actually not enough parallel data between every language pair that you care about, right? There's not like a dedicated parallel data set between Spanish and Malayalam, right? Or, just like you pick a random like permutation of two languages, right? So that makes it fundamentally hard to create a universal model that would do speech-to-speech, right? And then there's some very, again, this is where we go back to the previous conversation of really knowing the workflow and research at the same time, otherwise you're going to make the wrong decision, is that when you think of something like VOD dubbing, right? So today, when you sign up on our platform, you can put in a video and start editing it. And it'll dub it, but you can also make tweaks and such within it. Now, if you wanted to give a human the agency of interacting with the video, making changes, it becomes awfully difficult if you had a full speech-to-speech model. When you have a 1 degree of cascade you introduce that agency in between for a human to come in between and make any changes, right? And so, these are already two practical constraints that kind of rule out speech-to-speech in such use cases. But equally so, speech-to-speech, to my previous our previous discussion around on device, is equally useful because, why have two models? Why try to shove two models on the same space within a small device when you can have one model that can just fit on device? And that's where not having every language pair starts to make a lot more sense, because then you can kind of think about when it's going on device, it's not like a person themselves speak like 10 languages, right? As long as you have a speech-to-speech model that may be able to do the permutation between 6, they have an awesome universal translator that is fully private on their phone, right? So I think eventually, yes, things like that. And you can see some innovations from Samsung and the likes where they're trying to do this stuff, not fully speech-to-speech. No model today, I think, can claim to be fully speech-to-speech, that is at least in the public purview and such. But those are the types of applications where speech-to-speech already starts making practical sense, right?
Yeah.
And we have started exploring some techniques that do that, and they're quite interesting. But for now, I think cascading makes a lot of sense and lets you bootstrap a lot more things.
Gives more flexibility as well.
Yeah, just because then you're kind of locked in, chained into speech-to-speech, and then you have to get everything right in that speech-to-speech. So that's kind of the decision making there, and I think fair to say it'll remain true for a while.
So the fact that you're having two different models allows you to get inside of that process, of that workflow, and add additional context, additional features, and build around it. How are you not losing the context and the expressiveness when you're moving from text to speech?
Yeah, that's a great question. And so the goal of getting AI localization or video localization right has been a pipe dream for 20 years. It's not like we're the first people to think of it or try and solve it. But I think product-based companies that have tried to solve this problem have done it in more of a straightforward knee-jerk manner, right? Where it's like the obvious way to solve this problem is you take a video, you turn its speech to text, using any speech-to-text model like Whisper or whatever, may use some translation engine from Google or Amazon or Azure or whatever, and then you turn text into speech, right? The way I like to think of it is every step that you break, you lose heat to friction, right? Yeah. And that's very true about just from an information theoretic perspective of you just dissipating information every step, right? So that's definitely not the right way to do it, because it might work for like a simple corporate training video still, but it's not going to work for very complicated content, which, like I said, often doesn't even make sense in the language. Just today we do things as hard as not only sports, but even rap music. And you can kind of bend your imagination and think about what it takes to do that context, right? And so what our theory was that as long as we preserve as much meaning from the original content as possible, we'll then be able to transfer it over. So we cascaded the first two steps, which was the speech to text and translation, fused it together to build a model that took in speech directly and outputted translated text. Now, the advantage for that was that it had much higher awareness of even things like ambient noise to multiple speakers to the way the word was said. So often I think anybody can relate to this. Like you could say the same sentence many different ways as a question or something else. And yes, speech to text models sometimes can get, they can understand a question mark from a full stop, but there's many things that even the same sentence said slightly differently will translate very differently. And sarcasm is a great example. Humor is a great example where if you're not actually listening to what's happening, you'll get it wrong. And so that was the first inklings of us like creating BOLI, which is our model to take in kind of multimodal inputs and output translated text directly. And now we've kind of even, it's not that we've been, so we keep BOLI a tight guarded secret, because I think there's a lot of stuff that we've been able to do that actually creates a lot of value. But now we've extended it to be able to do multimodal cognition as well. So while, original system, I'll give you an example in like basketball, right? Like if there's a player that's just dribbling the ball and then takes the shot, right? What our technology is able to do is when the AI commentary is happening, the commentator will be a little bit more calm when he's dribbling the ball, but as soon as he takes the shot, it recognizes that there's something going on.
Nice.
Right? So it goes a level beyond just speech cognition to like fully understanding what content is. And that's really where, that's just one of the many things that we've been able to get right to really do this well.
So you're understanding even how the commentator is internally thinking about his speech.
Yes.
Getting that video stream and then analyzing the video stream and incorporating it
Yeah.
into your translation.
Yeah, and I love to call this the rocket science of generative AI because it involves every modality in a situation where there's no take backs.
No.
So it is always like flying a rocket.
And you're doing this for 140 now?
Yes.
140 languages?
Yeah.
How are you solving for all the languages or the dialects?
Yeah.
Are you using any transfer learning from different languages?
Yeah.
How are you scaling the language part?
Yeah, that's a great question. So, when we started the company, we started with a simple mission statement that the internet was made for English speakers like even me and you. And it's time to really redesign it for the world. And that part of the world is very important because we really don't want to leave any language behind. Today, if you give us around 1,000 to 2,000 hours of data, we can pretty much fine-tune our current existing models. And if we do the full retrain included in that, to start supporting that language. In fact, we're doing extremely meaningful work with a lot of indigenous communities through some of our partners in Canada and South America, where we're preserving full cultures with languages that have less than 600 speakers. And it's funny because I was just on call with that group like 2 days ago, and we're figuring out all ways that we can kind of get this done and make sure this happens, right? Which is a whole different effort in like data and stuff, right? But that's kind of where our technology is in covering each language. And the nice gift that we have at Camb.ai is that everybody working on this technology has lived with the problem. Everybody on our team speaks at least 2 to 3 languages. So beyond the business decisions or architectural decisions, they're more driven just from personal understanding of the problem, right? And so what is beautiful about that is when you see a language like Arabic, right? Arabic has many dialects. But if you're a research scientist in speech, and I can't give everything away, but if you're a research scientist in speech and you know Arabic and you know the many different dialects, there's actually quite a few smart tricks and things you can do to make it look to at least a machine that all these dialects look pretty similar, but the output to a human is actually in those genuine dialects, right? And, of course, not all of this work comes from smart tricks. Fundamentally, smart tricks break down in the face of data and lots of data, right? And we understand that. And so, we've been able to craft and make some extremely strategic partnerships with the likes of NBC, for example, which came out in the news just last week. So I'm allowed to talk about it now. But akin to what the Runway and Lionsgate deal for video gen, we partnered with NBC to take their content and fine-tune models like BOLI and MARS for extremely good Arabic dialect identification and differentiation and production, right? And that is something that, of course, I'm looking forward to, a lot of our team is looking forward to, and hopefully, 5-6 years from now, if you have like a toy robot that is speaking to you in a perfect some dialect of Arabic, it's probably a Mars model that was an output of this joint effort, because it's going to be hard to push with that kind of data and of course the lead and such that we have in speech.
Absolutely fascinating. I want to touch on some of the use cases, and you've talked about the sports use case. You're also doing film in the film industry, and you mentioned dubbing rap music.
Yeah.
So can you talk about the challenges for each briefly, and where do you think are the hardest use cases coming forward? I know this, you talked about how sport is the most difficult one that you did before, but where are you moving forward?
Yeah, I think one of the things that is extremely personal for us on our team, because we have some members of our team have faced this growing up, and this not just language localization, but even more the problem of accessibility, right? I'll give you a very, very small example, right? Like when I was, and this can like tie back to even personal experiences that most people face. It's like, try watching Top Gun without subtitles. If you're not used to a classic American accent, right? Which I have now a combination of, like, it's just a weird combination of. But when I was growing up in India, I used to watch these American films in theaters, and if I booked the unlucky show where it didn't have subtitles, I was like, wait, what did he just say? Or like, what just happened? And you kind of multiply that many times when you think about people who have, certain issues in vision or hearing. It becomes, you can kind of put yourself more in that shoe and think about what would that be multiplied by 100. So accessibility of content, not just localization of it in many languages, accessibility for no matter how you want to consume content in whatever language is becoming increasingly important for both Camb.ai and the world, right? And so some of the things that we're looking forward to is, especially in this world of multi-modality, of how do you make content accessible for genuinely everybody, whether that's the most basic thing of like subtitles and captioning, or to me, maybe even interesting things like audio descriptions, right? And I think that is something that we all are looking forward to, and we have some great partnerships and great customers already with some of that work. But that is something we're looking forward to. And kind of going back to the other use cases where you mentioned dubbing rap music, it sounds crazy, but again, like we could have either solved like 100 problems one by one, or we could have solved the hardest one first. And what solving for live sports and also a bit of music at the same time did is just gave us perspective on how bad this could be. Because one of the beautiful things about actually music is that your grandma will come into the room and you're playing around loud music, rap music, and she's like, what is this noise, right? Like, and when you actually objectively think about it, it's like, yeah, it kind of is noise sometimes. Like, no offense, but when we started working on this problem, I gained a whole profound respect for music artists and rap artists. The meaning is so deep. It is actually so deep that if you read it surface level, you'd be like, oh, what are they really talking about? But if you went 10 levels deep, it is absolute poetry. It's a new form of poetry. Might not be poetry from my culture, but absolute poetry, right? And the great challenge of building something like a translation engine like BOLI was, how do you understand all that context? How do you understand the deeper meaning to content? Because if you translated something like rap music word by word into another culture,
it doesn't make sense.
It'll be like, wait, what? It's like a bunch of words jumbled together. But to actually make music culturally relevant in every society not only meaningful and not only something that more and more people are consuming. You look at a lot of music artists doing cross-border collaborations. One of my favorite artists did one with my favorite Indian artist recently. So you see a lot more of this, but even just like the need to do it, and the need to do it in a way that's culturally adapted rather than just Google Translate it. No offense, right? Like,
I want to touch also, you've been building this also on AWS using things like Amazon Mechanical Turk and SageMaker and other services. If you're talking to the next person that's creating the new startup for AI for whatever idea, what are the learnings from using AWS services and using AWS in general that you want to share with new CTOs?
Yeah, absolutely. So I think I would take a step back and always think about it this way. As a CTO and as a person very invested in technology, you might rush to think about like, oh, what is the best framework, or how can I do this most efficiently, or what is the most scalable way for me to do this? What I've learned with my journey, and I genuinely mean this from the bottom of my heart, not just because I'm on this podcast, but AWS met us at a time when honestly, people told us you're not allowed to build such a company from Dubai, right? Very, very, very frankly speaking, you're dreaming too big, Akshat. Hold your horses. Some people still tell me that. I'm like, but AWS actually held our hand when we were nobody, right? And the story of Mars 5 that I'm telling you is much more of a story than just architectures, right? It's genuinely a story of how a company from Dubai made one of the best open source text-to-speech models ever with no resources. And AWS made that happen, right? And that says something. And when I've worked with more and more Amazonians and people from AWS, what I've realized is AWS is a great technology company, but it's an even better relationships company. It's an even better people company. And they really, I think it's safe to say every experience that I've had, it's about working backward from the business problem and then figuring out where AWS might fit in that, right?
Yeah.
And the one beautiful things that I've found from solution architects and great people around AWS is that it's not like, hey, use this service or that service. It's always like, what is the problem, right? Could I just call up somebody and solve your problem? Like, do we need tech? So this is kind of like really genuine experience with AWS on like solving the business problem, knowing what founders need, is you don't like find that like at all. And that's the special sauce at AWS, if I might reveal it.
Thank you.
But of course, beyond that, beyond training Mars 5, and there's a great case study out there for those of that are interested. When we launched Mars 6 on AWS Bedrock Marketplace, we trained Mars 6 on Hyperpod. And, we were working with a great set of folks. And the only reason we were able to make those timelines for the reInvent release, and, it was crazy. It's like we had a month, and we accelerated so fast using Hyperpod that it was just great. So Hyperpod was a great experience. And us, when you again think about it, like us going from Mars 5 to Mars 6, training a whole new model, getting it out, and launching it at reInvent. If you put yourselves in a founder CTO shoes, you can be like, it's not happening. But AWS made it happen, right? So there's examples of that, and there's many more. But I think that if that was one thing I was to pick out of AWS, it's that, and that's why any CTO, that's what a CTO should look for in AWS, which they'll very quickly find.
Wonderful. Any final thoughts before we finish about where do you think AI in general is moving, and where do you see the future?
Yeah, it's a broad question, but I think one thing that I keep realizing every day is that there's no brownie points for becoming an expert in AI. Everybody's an expert in AI these days, right? Like you see the LinkedIn profiles, and you're like, Okay, yeah. Like everybody knows apparently something about AI. I think what's more important as we're going forward is not become an expert in just AI, but become an expert in the problem, right? And that's where, again, Camb.ai I think is a great example of that, where today when you ask me about AI, of course I'm going to be able to tell you 100 things. But I feel like when you ask me about localization, I could tell you 1,000 things. Mm-hmm. And there's value in uncovering, like I mentioned, those last mile problems, which is where the moat is. So a lot of founders and a lot of even people that we're hiring in interviews, they've asked me this question that, oh, Akshat, you're building all these cool models and the team is doing so well and blah, blah, but you're going up against giants, right? Don't you feel that? Like Gemini and all these things and OpenAI and everybody's building crazy models. And I get good sleep at night because I know that, of course, we will build models that foundational models in speech or content understanding that are, at par, even better than what you might see right now. But what I'm very comfortable is that there's so many problems in the domain that we're working with that unless you are actually working in this space so deeply, you wouldn't even know which questions to ask. Yeah. And I think that is something that when I think about the future of AI or building great businesses within AI, I think that is what will differentiate real businesses versus businesses that can actually get rolled up just because somebody launched something. I think that is becoming increasingly important. And so you have to almost be dispassionate about being an AI expert because anybody could do it any other day, but you really need to know the problem you're solving. And it seems like a broken record, and I feel like any entrepreneur will say this and focus on your customers and focus on the problem. But now more so, it's you don't need a PhD in AI as much as you need a PhD in what you're solving. Yeah, and that I think is the future of AI and entrepreneurship and building a business in AI. I think while we stick to that and others stick to that, there'll be a lot of wins.
And it's recognized by customers of yours all around the world.
Yeah.
So, you must be doing something right.
We'd like to say so.
Yes. Thank you very much,
Thank you,
Ak. It was really wonderful speaking to you today.
Yeah, same here. I enjoyed it a lot.
We could continue this for hours.
Yeah, so, we can. Maybe afterwards.
Yes. Thank you very much.
Yeah, thank you.
And with that, we reach the end of our fascinating discussion with Akshat Prakash. The vision, motivation, and problem-solving mentality at Camb.ai are truly phenomenal, with the Mamba Mentality, for example. For those interested in learning more about Camb.ai, you can find links to their work on our show notes and fascinating tips and tricks in different papers that were released by ACT. If you enjoyed today's episode, please hit subscribe wherever you get your podcasts and leave us a rating and review. And as always, until next time, this is Hamza Mimi thanking you for listening. Keep exploring, keep innovating, and we'll catch you on our next episode.